Hello, and welcome to this quiet space. Find a comfortable position. Allow your body to feel heavy, supported, and at ease. Let go of the day, and as you begin to breathe, slowly and deeply, let us journey together. Tonight we travel beyond our world, beyond our galaxy, into the deepest reaches of the cosmos. We are going to visit a place of impossible scale, a structure so vast, so immense, that according to our understanding of the universe, it simply should not be there. It is a cosmic anomaly, a ghost in the grand design, known to us as the Great Wall. Imagine a universe that is, on its grandest scale, supposed to be smooth, uniform, like a calm and endless ocean. Now imagine finding a continent within that ocean, a continent made of galaxies, stretching farther than the mind can comfortably comprehend. This is the paradox we will explore tonight. But this is not a journey of complex equations or startling discoveries. It is a gentle drift, a quiet meditation on the sheer, silent, and beautiful mystery of everything. So close your eyes, breathe, and let us begin our voyage to the structure that should not exist. Before we arrive at our destination, it is helpful to understand the map of the cosmos as we once believed it to be drawn. For a very long time, scientists have held a belief known as the cosmological principle. It is a simple, elegant, and comforting idea. It suggests that if you were to look at the universe from a great enough distance, it would appear the same everywhere. No special places, no center, no edge. It would be homogeneous, meaning it has the same composition and properties at every point. And it would be isotropic, meaning it looks the same in every direction. Think of it like a fine mist, where every droplet is evenly spaced, and no matter where you stand within it, the view is identical. This principle was the bedrock of our cosmic understanding. It implied a certain predictability, a serene order to the grandest of scales. It suggested that while stars could form clusters, and clusters could form galaxies, there was a limit, a point at which things would smooth out into a gentle, uniform tapestry. This is the universe we expected to find, a universe of peaceful, predictable emptiness, dotted with predictable gatherings of light. But the universe, as we would soon discover, is far more intricate, far more textured, and far more surprising than our simple principles could have ever imagined. It is not a mist. It is a web. Let your mind drift now into the concept of this cosmic web. Do not try to grasp it with logic, but feel it as an image, a gentle thought. Picture the universe not as a void with scattered points of light, but as a delicate, three-dimensional structure, a shimmering, near-infinite lattice. This structure is composed of long, luminous threads, known as filaments. These filaments are rivers of galaxies flowing through the ages, pulled together by the gentle, persistent whisper of gravity. They twist and turn, weaving through the darkness, connecting at bright, bustling intersections. These intersections are the great superclusters, cities of light where thousands of galaxies live in close proximity, their gravitational fields overlapping, their stars mingling their ancient light. Between these threads, in the vast, open spaces, lie the great cosmic voids. These are regions of profound emptiness. Imagine immense, dark bubbles where the silence is absolute and the distance between galaxies is almost incomprehensible. It is a structure of both profound connection and profound isolation. This is the true architecture of our universe. It is a foam of space-time, where existence congregates along the thinnest of membranes, leaving the interiors of the bubbles almost entirely empty. As you breathe in, imagine pulling in the faint light from these distant filaments, and as you breathe out, imagine releasing your thoughts into the peaceful silence of the cosmic voids. Our journey tonight takes us along one of the most magnificent of these filaments, a thread so long, so dense with galaxies, that it challenges the very idea of a smooth and uniform cosmos. It is here, within this grand, delicate web, that we will find our anomaly, our great wall. To understand the discovery of this impossible structure, we must travel back in time, not just through space. Let your mind settle in the year 1989. The world was a different place, but the night sky was the same. Astronomers Margaret Geller and John Hucra were working at the Harvard-Smithsonian Center for Astrophysics. They were not searching for cosmic monsters or anomalies. Their goal was simple, yet ambitious, to create a map of our local corner of the universe. They were conducting something called a redshift survey. It is a wonderfully elegant way to measure the cosmos. As the universe expands, distant galaxies are carried away from us. The light they emit is stretched on its long journey, shifting towards the red end of the spectrum. The more distant the galaxy, the greater its redshift. By measuring this subtle change in color, Geller and Hucra could determine not just the direction of a galaxy, but its distance as well. They were creating the first truly three-dimensional map of the cosmos. For years, they pointed their telescopes at slice after slice of the sky, collecting data point by point, galaxy by galaxy. They were like patient cartographers charting an unknown continent. They expected to find a relatively even distribution of galaxies, confirming the comforting cosmological principle. But as the data points accumulated, a strange and startling picture began to emerge on their screens. A pattern, a structure, something immense and connected, stretching across their entire field of view. It was not a random scattering. It was a line, a sheet, a wall of galaxies standing silently in the cosmic dark. They had stumbled upon something that shouldn't be there, and the map of the universe would never be the same. Let us try to comprehend the scale of what they found. The human mind is not built to grasp such numbers, so we must use metaphor and imagination. Breathe slowly and let these images form without effort. First, picture our own galaxy, the Milky Way. It is a vast, spinning island of stars, about 100,000 light years across. It is a magnificent home filled with billions of suns. Now imagine holding a single grain of sand. Let that grain of sand represent our entire Milky Way galaxy. The Great Wall, this structure that Geller and Hucra discovered, would be a line of sand stretching over 100 feet long, a filament of galaxies, side by side, extending for a distance of more than 500 million light years. Its length is staggering, but consider its other dimensions. It is approximately 300 million light years wide and about 15 million light years thick. It is not a wall in the solid sense, like one made of brick and mortar. It is more like a lace curtain woven from entire galaxies, superclusters and glowing gas hanging in the darkness. To cross it from one side to the other, traveling at the speed of light, would take 15 million years. The light from the farthest galaxies in the wall began its journey to us before the first complex life emerged on Earth. It is an ancient, colossal structure, a testament to the slow, patient, and powerful forces that shape our universe. As you rest here, feel the immense space around you. Feel the quiet presence of this silent galactic continent floating in the endless night. Its scale does not diminish us. It simply shows us the grandness of the home we are a part of. Now, let us float closer and examine the composition of this celestial wall. As we mentioned, it is not a solid object. It is a congregation, a gathering. Imagine drifting through it. You would not collide with a hard surface. Instead, you would find yourself surrounded by a higher density of galaxies than in the voids around it. It is like flying from the sparse countryside into the sprawling suburbs of a giant city. The lights become more frequent, the landmarks more numerous. The Great Wall is primarily composed of several massive superclusters of galaxies. These are the knots in the cosmic web, the downtown cores of this galactic metropolis. One of the most famous residents of the wall is the Coma supercluster. This is one of the first superclusters ever discovered, a rich and dense collection of over 3,000 galaxies, bound together by their mutual gravity. Imagine the view from a planet within the Coma supercluster. The night sky would not be a dark canvas with pinpricks of light. It would be ablaze with the soft glow of thousands of neighboring galaxies, some so close they would appear as brilliant smudges of light, their spiral arms visible to the naked eye. It would be a sky of breathtaking beauty, a constant reminder of cosmic community. Another major component is the Hercules supercluster. Each of these superclusters is itself a colossal entity, millions of light years across. The Great Wall is the structure that connects them, a bridge of galaxies and intergalactic gas, a celestial highway linking these great cosmic cities. It is a place of immense gravitational influence, a region where the fabric of space-time is gently warped and curved by the combined mass of trillions of stars. As you drift in this thought, feel the gentle pull of gravity, the force that builds worlds, stars, and even these magnificent walls of light. Let us pause our exploration of the wall itself and drift for a moment into the spaces that define it, the great cosmic voids. To appreciate the light, we must understand the darkness. To appreciate the structure, we must experience the emptiness. The voids are the largest features in the universe, the great bubbles in the cosmic foam. As we move away from the dense filament of the Great Wall, the galaxies begin to thin out. The sky grows darker, quieter. We are entering a realm of profound solitude. A typical void can be hundreds of millions of light years in diameter. If our Milky Way galaxy were located in the center of a void, we would not have known of the existence of other galaxies until the 1960s. The night sky would have been almost completely dark, save for the stars of our own island universe. The silence in these voids is a concept that transcends sound. It is a silence of matter, of energy, of existence itself. The temperature here plummets to near absolute zero. The density of matter is a tiny fraction of the universal average, and yet they are not entirely empty. Faint, lonely dwarf galaxies sometimes wander through the emptiness. wisps of primordial hydrogen gas, remnants from the Big Bang, drift like cosmic ghosts. And of course, the voids are filled with the mysterious dark energy that drives the expansion of the universe, and the equally enigmatic dark matter whose gravitational influence can still be felt, however faintly. Breathe in the coolness of this empty space. Feel the peace of this profound solitude. It is this emptiness that gives the cosmic web its shape. The filaments and walls are not just structures in their own right. They are the boundaries of these great, silent voids. The universe is a delicate balance of everything and almost nothing. Now, returning our focus to the luminous thread of the Great Wall, let us re-examine the principle it seemed to shatter. The cosmological principle. The idea that the universe is smooth and uniform on large scales. The discovery of a connected structure 500 million light years long was a direct challenge to this idea. It was like surveying an ocean and finding a wave that stretched halfway across it. It was simply too big. According to the models of the universe based on the Big Bang, there hasn't been enough time for gravity to assemble a structure of this magnitude. Gravity is a powerful force, but it is also a slow one. It pulls matter together over eons. For a structure as long as the Great Wall to form, different parts of it, hundreds of millions of light years apart, would have needed to communicate gravitationally. But there's a speed limit in the universe, the speed of light. And in the 14 billion years since the universe began, there simply hasn't been enough time for a single gravitationally bound object of this size to coalesce. This led to a profound question for cosmologists. Was the Great Wall a single, coherent object bound by its own gravity? Or was it something else? A chance alignment? A line of sight trick of perspective? This is the heart of the anomaly. The structure is undeniably there. The data is clear. But its existence strains the very limits of our understanding of how the universe evolves. It suggests that perhaps our models were too simple. Perhaps the universe is lumpier, more textured, on larger scales than we ever anticipated. The Great Wall stands as a quiet monument to the humility required in science. A reminder that the cosmos is always ready to surprise us, to challenge our assumptions, and to reveal a deeper, more complex beauty. This leads us to a concept known as the end of greatness. It is a poetic name for a scientific idea. The end of greatness is the theoretical scale at which the lumpiness of the universe should average out, the scale at which the cosmological principle should finally hold true. Think of it like flying high above a forest. From close up you see individual trees, clearings, and hills, a very textured, non-uniform landscape. But as you ascend higher and higher, these individual features blend together. Eventually, from orbit, the forest looks like a smooth, green patch on the planet's surface. The texture has disappeared. The view has become homogeneous. Scientists had calculated this scale for the universe. Based on their models, they predicted that structures larger than a few 100 million light years should not exist. At that scale, the universe's structure should smooth out into that gentle cosmic mist. The CFA2 Great Wall, at 500 million light years, was sitting right on the edge of this theoretical limit, and perhaps even beyond it. It was as if, from orbit, you could still make out a single, impossibly large tree that dominated the entire forest. This discovery forced a re-evaluation of where the end of greatness truly lies. Perhaps the universe smooths out on a much, much larger scale than we thought. Or perhaps our understanding of how these structures form from the initial seeds of the Big Bang is incomplete. The Great Wall became a cosmic yardstick, pushing the boundaries of our theories. It whispers to us across the vastness of space, telling us that the story of cosmic structure is grander, more dramatic, and more epic than we had ever dared to imagine. As you rest, let your mind expand to this scale, a scale where even greatness has an end, but an end that is much farther away than we ever knew. So, how do such colossal structures form, even if they push the limits of our theories? The story begins just after the beginning of time itself. In the fiery, dense infancy of the universe, just moments after the Big Bang, the cosmos was a nearly perfect, uniform soup of particles and energy. But it was not completely perfect. There were tiny quantum fluctuations, microscopic variations in density from place to place. Imagine a perfectly still pond, and then a single gentle breeze creates the faintest, almost invisible ripples on its surface. These quantum fluctuations were the ripples on the pond of the early universe. As the universe expanded and cooled, these tiny ripples were stretched to enormous, astronomical scales. The regions that were infinitesimally denser than their surroundings began to exert a slightly stronger gravitational pull. Over millions and then billions of years, this process continued. Gravity, patient and relentless, amplified these initial tiny seeds. The denser regions pulled in more and more matter, becoming the cosmic filaments and superclusters we see today. The less dense regions gave up their matter, becoming the great cosmic voids. The Great Wall is one of the most successful results of this process. It is the culmination of 14 billion years of gravitational accumulation, a magnificent structure that grew from a quantum ripple smaller than an atom. It is a beautiful illustration of how the largest things in the universe have their origins in the very smallest. It is a story of cosmic patience, a reminder that great things can grow from the humblest of beginnings, given enough time. As you breathe, feel the deep, slow rhythm of cosmic time, the patient force that builds walls of light from nearly nothing. We cannot tell the story of the Great Wall without speaking of its invisible architect, dark matter. The galaxies, the gas, and the dust that we can see, the luminous matter that forms the wall, is only a tiny fraction of what is actually there. It is like seeing the lights of a city at night without seeing the buildings, the streets, or the ground they are built upon. The vast majority of the mass in the Great Wall, and indeed in the entire universe, is made of a mysterious, invisible substance that we call dark matter. We cannot see it. It does not emit or reflect light, but we know it is there because we can feel its gravity. It is the hidden scaffolding upon which the cosmic web is built. In the early universe, it was the gravity of dark matter that first began to clump together, forming vast, invisible halos. The normal matter we see, the stuff of stars and planets, was then drawn into these halos, like cosmic dust, settling into an invisible spider's web. The Great Wall is, in essence, a massive, elongated halo of dark matter, decorated with the galaxies we can observe. The visible galaxies are just the luminous foam on a deep, invisible ocean of dark matter. When we look at the Great Wall, we are only seeing the tip of the cosmic iceberg. Its true mass, its true gravitational influence, is hidden from our eyes. This adds another layer of mystery and wonder to the structure. It is not just a wall of light, but a wall of gravity, a profound concentration of a substance we do not yet understand, which silently and powerfully dictates the structure of our cosmos. Allow your mind to rest in this comfortable darkness, feeling the presence of the unseen, the quiet, powerful force that holds the universe together. How can we be so sure about these invisible structures and ancient processes? One of the most powerful tools astronomers use is the computer simulation. They can create virtual universes inside a supercomputer, allowing them to watch cosmic history unfold. They start with the known ingredients of the universe: normal matter, dark matter, and dark energy. They input the initial conditions we observe from the cosmic microwave background, that faint afterglow of the Big Bang with its tiny temperature fluctuations. Then they press play and let the laws of physics, primarily gravity, do their work over billions of years of simulated time. What emerges in these simulations is astonishing. A cosmic web, almost identical to the one we observe in the real universe, forms all on its own. Virtual filaments, voids, and superclusters coalesce from the initial smooth state. These simulations show us that the cosmic web is the natural, expected outcome of our current understanding of physics. And within these simulated universes, structures very similar in size and shape to the Great Wall do occasionally form. They are rare. They are at the extreme upper end of what is statistically likely, but they are not impossible. This gives scientists confidence that our theories are on the right track. The simulations help us bridge the gap between the beginning of time and the universe we see today. They allow us to test our ideas and explore the what-ifs of cosmology. They are like a cosmic time machine, allowing us to witness the patient construction of the universe, from the first flicker of creation to the majestic, silent structures that now adorn the cosmic night. As you drift, imagine watching one of these simulations, a universe blooming like a flower in fast motion, its beautiful web-like petals unfolding in the digital dark. This brings us to a subtle but important debate among astronomers. Is the Great Wall truly a single, gravitationally bound structure? Or is it more of a pseudo-structure, a chance alignment of several smaller, distinct groups of galaxies that just happen to line up from our particular vantage point in the Milky Way? The distinction is crucial. If it is one single, coherent object held together by its own immense gravity, then it truly breaks the models. It would mean that our understanding of the speed at which structures can form is fundamentally flawed. However, if it is a lineup, a cosmic coincidence, then it is less of a challenge to the standard model of cosmology. It would still be a magnificent and rare feature, but not one that rewrites the physics books. This is a difficult question to answer. To determine if a structure is gravitationally bound, you need to measure the individual motions of its member galaxies very precisely. Are they moving together, orbiting a common center of mass, or are they just passing each other by? part of the overall expansion of the universe, the Hubble flow. The initial observations of the Great Wall were not detailed enough to resolve this. It is like looking at a distant flock of birds. From afar, they look like one object. But are they flying together as a coordinated flock, or are they several separate groups that just happen to be in the same part of the sky? Subsequent surveys and more detailed analysis have suggested that the Great Wall is likely not one single monolithic entity. It seems to be a collection of several superclusters and smaller groups, a particularly dense and long filament in the cosmic web, but perhaps not a single bound object. This makes it slightly less anomalous, but no less spectacular. It is a masterpiece of cosmic architecture, whether it is one building or a beautifully aligned city skyline. Let us delve deeper into this idea of gravitational binding. Imagine a family of stars, an open cluster. The stars are all born from the same cloud of gas and are bound together by their mutual gravity. They travel through the galaxy as a cohesive unit. Now imagine a city of stars, a galaxy. It is also gravitationally bound. Our sun orbits the center of the Milky Way, held in place by the combined gravity of billions of other stars. Superclusters are more tenuous. The galaxies within them are bound, but more loosely. They move and interact. But over vast timescales, they are a coherent group. The question for the Great Wall is whether this binding extends across its entire 500 million light-year length. The current consensus is that it does not. The different superclusters that make up the wall, like the Coma and Hercules superclusters, are themselves gravitationally bound entities. But the long, stringy filaments of galaxies that connect them are likely not. They are part of the same river of matter, flowing in the same general direction, shaped by the same large-scale gravitational currents. But a galaxy at one end of the wall feels no direct binding pull from a galaxy at the other end. The immense distance and the ever-present expansion of the universe in between them prevents that. So, the Great Wall is less like a solid chain and more like a string of pearls, where each pearl is a magnificent supercluster, and the string itself is a filament of galaxies, all part of the same cosmic flow. This understanding makes the Great Wall fit more comfortably within our cosmological models, while doing nothing to diminish its grandeur. It is a testament to the hierarchical nature of cosmic structure, from star clusters to the vast, interconnected web itself. It is important to know that the CFA2 Great Wall is not alone in the cosmic zoo of megastructures. Since its discovery, astronomers, armed with more powerful telescopes and capable of surveying even larger volumes of space, have found other, even more colossal structures. In 2003, the Sloan Digital Sky Survey, a project that mapped millions of galaxies, revealed the Sloan Great Wall. This structure is even more immense, stretching for a mind-boggling 1.4 billion light years. It is nearly 3 times longer than the original Great Wall. Its discovery further cemented the idea that the universe is structured on these enormous scales. The Sloan Great Wall also appears to be a filamentary collection of superclusters rather than a single bound object. It lies much farther away from us, and so we see it as it was much earlier in the universe's history. Then, in 2013, astronomers analyzing the distribution of gamma ray bursts, the most powerful explosions in the universe, found evidence for an even larger structure. The Hercules Corona Borealis Great Wall. Its estimated size is a staggering 10 billion light years across. This is so large that it occupies more than 10% of the diameter of the entire observable universe. This structure is highly controversial. Its existence is inferred indirectly, and many scientists believe it may be a statistical illusion, a random clustering of events, rather than a true physical structure. But if it is real, it completely shatters the cosmological principle. It would mean the universe is not homogeneous, even on the very largest scales we can observe. These subsequent discoveries place the original Great Wall in a new context. It was the first of its kind to be found. The first hint that our cosmic neighborhood was far more structured than we ever dreamed. It opened the door to finding these other cosmic giants, each one pushing the boundaries of our understanding a little further. Let's take a moment to consider the fabric of the universe itself. According to Einstein's theory of general relativity, space and time are not a passive backdrop for events to unfold. They are a dynamic, interwoven fabric. Space-time. Massive objects, like stars, planets, and galaxies, warp and curve this fabric around them. This curvature is what we experience as gravity. Now imagine the effect of a structure like the Great Wall. This is not just a single galaxy or a star. It is a concentration of mass on an unbelievable scale, trillions of solar masses gathered in a single, elongated region of space. The gravitational influence of the Great Wall is immense. It creates a vast, gentle depression in the fabric of space-time. It forms what is known as a gravitational potential well. Other, smaller galaxies and clusters of galaxies that are nearby will be slowly, inexorably pulled towards it over the course of cosmic history. Light itself, as it travels from more distant objects and passes by the Great Wall, will have its path bent by this curvature of space-time. This effect, called gravitational lensing, is a powerful tool for astronomers, allowing them to use massive structures like the Great Wall as natural telescopes to study the universe. Behind them, the wall is not just a passive resident of the cosmos, it is an active participant. It shapes the very geometry of the space around it. It dictates the flow of matter and energy on a scale of hundreds of millions of light years. As you rest, imagine this invisible landscape of space-time with its mountains, valleys, and great plains, all sculpted by the silent, patient hand of gravity. Let us consider the dual nature of our view of the Great Wall, its existence in both space and time. Because of the finite speed of light, when we look out into the cosmos, we are also looking back into the past. The light from the moon takes a little over 1 second to reach us. We see it as it was 1 second ago. The light from the sun takes 8 minutes. The light from the nearest star, over 4 years. The Great Wall is located roughly 200 million light years away from Earth. This means the light we are seeing from its galaxies tonight, the light that Geller and Hukra captured on their photographic plates, began its journey 200 million years ago. At that time, on Earth, the first dinosaurs were just beginning to walk the planet. The continents were merged into the supercontinent of Pangaea. The world was a completely different place. For all that time, for 200 million years, that faint, ancient light has been traveling across the expanding universe, through the silent voids, past other galaxies, on a direct course for our tiny planet, our telescopes, and our eyes. We are not seeing the Great Wall as it is today. We are seeing a snapshot of it as it was in the distant past. It has aged 200 million years since that light left. Its galaxies have continued to evolve. Stars have been born and have died. Perhaps some of its galaxies have merged. We can only speculate on what it looks like now. This is the profound nature of astronomy. It is a form of time travel. We are cosmic archaeologists studying the ruins of ancient light to piece together the history of the universe. So, as you visualize the Great Wall, see it not as a static object, but as a moment in time, a postcard from a long-lost era of the cosmos. Where did the blueprints for such a grand structure come from? The answer lies in the faintest whisper from the dawn of time, the cosmic microwave background, or CMB. The CMB is the residual heat from the Big Bang, a faint glow of microwave radiation that permeates the entire universe. It is the oldest light we can see, an image of the universe when it was only 380,000 years old. At that time, the universe was a hot, dense, opaque fog. The CMB is the moment that fog finally cleared and light could travel freely for the first time. When we map the CMB across the sky, it is incredibly uniform, the same temperature in every direction. This uniformity is the strongest evidence for the cosmological principle. However, if we look very closely, with incredibly sensitive instruments, we find tiny variations in that temperature. Fluctuations that are only 1 part in 100,000. These tiny hot and cold spots in the baby picture of the universe are the seeds of all cosmic structure. They correspond to the tiny density variations, the quantum ripples that we spoke of earlier. The slightly hotter, denser spots in the CMB were the places where gravity had a slightly stronger grip. These are the locations where, over the next 14 billion years, matter would congregate. They were the seeds that would eventually blossom into the superclusters and filaments that form the Great Wall. The slightly colder, less dense spots were the seeds of the great cosmic voids. When we look at the Great Wall and then at the map of the CMB, we are seeing a cause and its ultimate effect separated by billions of years of cosmic evolution. It is a beautiful, direct link between the quantum world of the early universe and the grand, galactic architecture of today. Let us continue with this thought, the growth of these cosmic seeds. Imagine the universe in its youth, filled with a smooth, expanding gas of hydrogen and helium, and of course, the invisible dark matter. The only features were these incredibly faint, large-scale ripples of density imprinted from the Big Bang. Now picture gravity as a slow, patient sculptor. It began to work on this smooth material. The denser regions, the future filaments, began to pull in matter from their surroundings. The process was incredibly slow. For the first billion years, not much seemed to happen on the large scale, but gravity never stops. The denser regions became denser still. The less dense regions became emptier. Slowly, the smooth soup began to curdle. The first small dark matter halos formed, and within them, the first galaxies began to light up. These galaxies were then drawn towards each other, forming groups and clusters. And these clusters were drawn along the lines of the initial density fluctuations, falling into the great filaments that were beginning to take shape. The Great Wall is not something that was built and then stopped. It is a dynamic, evolving structure, still in the process of formation. It is a river of galaxies, and it is still flowing. Galaxies are continually being drawn into its filaments from the surrounding voids. Clusters along its length are merging and growing. It is a living, breathing part of the cosmic ecosystem. The universe is not a static museum of finished objects. It is a work in progress, and we are fortunate enough to have a glimpse of it during its long, slow, and magnificent creation. As you lie here, feel the sense of ongoing creation, the slow, inevitable, and beautiful dance of gravity shaping the cosmos. A helpful way to visualize this entire cosmic structure is to think of a universe made of bubbles. Imagine blowing bubbles in a thick, soapy liquid. The bubbles expand and press against each other. The soap film arranges itself into flat walls where two bubbles meet, and into long, thin threads where three bubbles meet. The vast majority of the volume is inside the bubbles, which are filled with air. The vast majority of the soap film is concentrated in the walls and threads between them. The cosmic web is remarkably similar. The great cosmic voids are the bubbles. They are expanding, pushing matter out of their interiors. The galaxies and clusters are like the soap film. They are squeezed into the spaces between the expanding voids. Where two void bubbles meet, we get a flat sheet of galaxies, sometimes called a wall. Where three or more voids meet, the matter is concentrated into a dense, long filament. The superclusters are the bright, busy intersections where several filaments come together. The CFA2 Great Wall is one of the most prominent examples of such a structure, a place where several ancient voids have pressed together, concentrating galaxies into a vast, sheet-like arrangement. This bubble analogy helps us understand why the universe is so empty in some places and so full in others. It's a natural consequence of this expanding, bubble-like structure. It also helps us appreciate the delicate beauty of the cosmic web. It is a fragile, ephemeral structure, like a soap bubble, but on a scale of billions of light years and with a lifespan of eons. Breathe in and imagine these silent cosmic bubbles expanding. Breathe out and see the galaxies gathering like dew along the delicate films between them. Let us turn our attention back to the light itself, the ancient light that travels from the galaxies within the Great Wall. What does this light tell us? Each photon, each particle of light, is a messenger carrying a story. By analyzing the spectrum of this light, by breaking it down into its constituent colors, astronomers can learn a tremendous amount. They can confirm the galaxy's redshift, and thus its distance. They can determine the chemical composition of the galaxy's stars and gas. They can tell if it is an old galaxy, made mostly of red, aging stars, or a young galaxy, blazing with the blue light of vigorous star formation. They can even measure how fast the galaxy is rotating. When we study the galaxies in the Great Wall, we find a rich diversity. There are giant elliptical galaxies, old, quiescent cities of stars, often found in the dense hearts of the superclusters. There are beautiful spiral galaxies, much like our own Milky Way, actively forming new stars in their graceful arms. There are smaller, irregular galaxies, perhaps distorted by gravitational encounters with their larger neighbors. The light tells a story of galactic evolution in a dense, cosmic environment. It tells us that the Great Wall is not just a place of structure, but a place of history, a place where galaxies have been interacting, merging, and evolving for billions of years. Each point of light in that wall is a world, a system, a history, a collection of billions of stars and potentially billions of planets. The light is not just data. It is the collected story of trillions of lives, both stellar and perhaps elsewhere. Biological. As you rest, let your mind be open to these silent stories, whispered by ancient light across the immense, dark void. Let us once again contrast the richness of the wall with the profound emptiness of the voids it borders. Imagine you are in a spacecraft, leaving the bustling Coma supercluster, a core part of the Great Wall. As you travel, the vibrant galaxies in your view screen begin to recede. Their soft, extended glows shrink to pinpoints of light, and then, one by one, they fade from view. You are entering the Bode's Void, a famous cosmic desert that lies adjacent to the region of the Great Wall. The darkness ahead is almost absolute. The silence is not just an absence of sound, but an absence of everything. For millions of light years, you would see almost nothing. The familiar landmarks of the cosmos are gone. The temperature of space here is as cold as it can get. The gravitational field is incredibly weak, almost perfectly flat. It is a place of serene and perhaps intimidating tranquility. To float in the center of a void is to experience the universe in its most fundamental state, vast, dark, and expanding. It is a meditative, humbling experience. After a journey of tens of millions of years at near light speed, you might, if you are lucky, encounter a single, lonely galaxy, a small, faint island of light in an endless ocean of night. These void galaxies are fascinating objects. They have lived their entire lives in isolation, untouched by the gravitational turmoil of clusters and walls. They are pristine laboratories for studying how galaxies evolve without outside interference. The voids are as important to the cosmic story as the walls. They are the other half of the universe's personality. The quiet, contemplative yin to the vibrant, chaotic yang of the filaments. To understand the universe, we must embrace both its fullness and its emptiness. After journeying so far, it is natural to ask, where are we in all of this? What is our own place within this grand cosmic web? For a long time, we thought the Milky Way was part of a modest structure called the Virgo supercluster. But in 2014, a new mapping technique revealed a much grander truth. Our galaxy, the Andromeda Galaxy, the Virgo cluster, and about 100,000 other galaxies are all part of a single massive supercluster. Its name is Laniakea, a Hawaiian name that means immeasurable heaven. Laniakea is a colossal structure, over 520 million light years in diameter. It is our home supercluster, and it is, itself, a filament in the even larger cosmic web. We are not located in a dense wall like the Great Wall, nor are we lost in a great void. We live in the suburbs of the cosmic city, a beautiful, sprawling arm of a galactic continent. The discovery of Laniakea was made by mapping the motions of galaxies. All the galaxies within Laniakea are flowing towards a single point, a gravitational anomaly known as the Great Attractor. This region is the gravitational center of our supercluster, a valley in the landscape of space-time, into which we and our neighbors are slowly falling. Knowing our cosmic address gives us a profound sense of place. We are not random specks of dust. We are residents of the Milky Way galaxy, which is part of the local group, which is on the outskirts of the Virgo cluster, which is a component of the great Laniakea supercluster. We are connected. We are part of a structure, a flow, a history that is billions of years old and hundreds of millions of light years wide. As you breathe, feel this connection. Feel yourself as part of this immense, flowing, heavenly structure. What is the ultimate fate of the Great Wall? Will this magnificent structure last forever? The answer to this question lies in the cosmic battle between two opposing forces, gravity and dark energy. Gravity is the force of attraction. It is what pulled the Great Wall together, what holds its superclusters intact, and what continues to draw new galaxies into its filaments. Gravity wants to build things, to make the universe lumpier and more structured. For the first several billion years of the universe's history, gravity was the dominant force on large scales. But there is another player on the cosmic stage, dark energy. This is a mysterious, repulsive force, an intrinsic property of space itself that causes the expansion of the universe to accelerate. While gravity tries to pull things together, dark energy tries to push everything apart. Currently, on the scale of superclusters like those in the Great Wall, gravity is still winning. The galaxies within the Coma cluster will remain bound together. However, on the very largest scales, the scales that connect the different superclusters within the wall, dark energy is beginning to dominate. The expansion of space between the Coma and Hercules superclusters is accelerating. This means that over billions of years, the Great Wall will be slowly, gently stretched apart. The filaments connecting its great cities will thin out, and eventually the superclusters that form the wall will recede from each other's view, each becoming an isolated island universe in an ever-expanding, ever-emptier cosmos. The Great Wall, like all the great structures of the cosmic web, is a temporary masterpiece. It is a beautiful arrangement that has existed for a time, but will eventually be dismantled by the quiet, persistent push of dark energy. This does not make it less wonderful. It makes it more precious, a fleeting moment of cosmic grandeur. Let's take a moment to reflect on the philosophical implications of such a structure. The existence of the Great Wall and the cosmic web in general changes our perspective on our place in the universe. It shows us a cosmos that is not random, but is deeply and beautifully structured. There is an architecture to reality, an underlying pattern that is both complex and elegant. On one hand, the sheer scale of the wall can be humbling. Our entire existence, all of human history, has played out on a tiny planet orbiting a single star in one of trillions of galaxies that make up this one structure, among countless others. It places our own concerns and our own importance in a vast perspective. It reminds us that we are part of something immeasurably larger than ourselves. On the other hand, it can be empowering. The fact that we, from our tiny vantage point, are able to perceive this structure, to map it, to understand its origins in the first moments of time, is a testament to the power of the human mind and the spirit of inquiry. We are the universe's way of knowing itself. We are the consciousness of the cosmos, looking out at its own form. The Great Wall is not just a scientific object. It is a mirror. In its silent galactic face, we see both our own insignificance and our own significance. It invites us to be humble, and it invites us to be curious. It is a source of awe, and awe is a deeply restorative and peaceful emotion. As you rest, allow yourself to feel this sense of awe, this peaceful connection to the grand, silent structure of everything. Let us take one final meditative journey along the length of this cosmic filament. Close your eyes if you haven't already, and just allow the images to flow. We begin our journey in the outskirts of the Hercules supercluster. All around us, galaxies of all shapes and sizes drift like luminous ships in a celestial sea. We move slowly, peacefully, along a river of stars. We pass by ancient red elliptical galaxies, their light a soft, golden glow. We glide past brilliant blue spiral galaxies, their arms swirling with the fire of new star birth. Between the galaxies, the space is not entirely empty. We feel the presence of the invisible, dark matter, and we see faint wisps of glowing hydrogen gas, the raw material for future stars. Our journey continues for millions of years, condensed into a few peaceful moments of thought. We are following the gentle curve of space-time, the path laid out by gravity over eons. The view is constantly changing, yet fundamentally the same, a river of light flowing through the dark. After a long, peaceful drift, we begin to see the density of galaxies increase. The lights become more frequent, more brilliant. We are approaching the heart of another great city. We are arriving at the Coma supercluster. Here, the gravitational tides are stronger, the dance of galaxies is faster, more intricate. Thousands of galaxies are packed into a relatively small volume of space, a bustling, brilliant metropolis of stars. We have traveled along just a portion of this great wall, this magnificent testament to the universe's ability to create structure and beauty on the most breathtaking scale imaginable. Let this image of a silent, flowing river of light be your final thought as you drift deeper into rest. A river of which you and everything you know are a tiny, precious part. As our journey through the cosmic web concludes, let's consider the delicate interplay between observation and understanding. For most of human history, the universe was the scattering of stars we could see with our naked eyes, a beautiful but seemingly two-dimensional canopy. The invention of the telescope revealed the existence of other galaxies, turning our canopy into a vast, three-dimensional space. But it was the redshift survey, the patient, meticulous work of Geller and Hucra, that truly unveiled the underlying architecture. It was like switching from a simple photograph to a topographical map, revealing the hidden mountains and valleys for the first time. The Great Wall was not discovered in a single eureka moment. It emerged slowly, data point by data point, from the noise, It was a pattern that revealed itself only when enough of the puzzle pieces were in place. This is often how science progresses. Not through sudden flashes of genius, but through dedication, patience, and the slow accumulation of evidence. The universe does not give up its secrets easily. We must ask the right questions, and then we must listen very carefully for the faint, ancient answers. The story of the Great Wall is a story of listening to the stretched out light of distant galaxies, and hearing the story of a structure that wasn't supposed to be there. It reminds us that there is always more to see, always a deeper layer of reality to uncover. The map is not the territory, and our current map of the cosmos is surely incomplete. What other, even grander structures lie, waiting in the darkness, waiting for a patient observer to connect the dots and reveal a new feature of our incredible cosmic home? Let us think about the name itself, the Great Wall. It is a human name for a human concept. We project our own experiences onto the cosmos. A wall is something that divides, that separates, that blocks the way. But the cosmic Great Wall does not do this. It is not a barrier. It is a connection. It is a congregation. It is a place of gathering. It is a luminous thread that weaves disparate parts of the universe together. Perhaps a better name would be the Great River or the Great Bridge. But the name wall sticks because it so powerfully conveys the sense of scale, the sense of a single immense feature standing out against the emptiness. It also carries a sense of mystery, of confrontation. It confronted our old ideas about the universe. It stood as a barrier to our simplistic models. In that sense, the name is perfect. It is a wall that forced our understanding to find a way around it, to grow, to become more sophisticated. The names we give to celestial objects, nebulae named after animals, constellations named after myths, tell us as much about ourselves as they do about the objects themselves. They are a reflection of our attempt to find meaning, pattern, and familiarity in the vast, impersonal cosmos. The Great Wall is a powerful name for a powerful idea that the universe is not just empty space, but is full of majestic and challenging structures that invite us to look deeper and to think bigger. It is a landmark in our intellectual journey, a waypoint on our map of understanding. Imagine the perspective of a civilization that might evolve within the Great Wall itself, perhaps in the dense core of the Coma supercluster. Their night sky would be a spectacle beyond our wildest dreams. It would be filled not with stars, but with galaxies, thousands of them, visible to the naked eye, hanging in their sky like ethereal lanterns. Their mythology would not be about constellations of stars, but constellations of galaxies. Their astronomers would have known about the larger universe from their very earliest days. The concept of an isolated island universe would be entirely foreign to them. They would see their place in a bustling, crowded cosmos as self-evident. But they might have a different cosmic mystery. For them, the great voids would be the profound puzzle. They might look out from their luminous home into the profound blackness between the filaments and wonder. What is out there in that great, silent emptiness? Is our wall the only place where life and light exist? Their cosmological principle might be that the universe is, by its nature, full and structured, and the existence of such profound emptiness would be the anomaly they would struggle to explain. It is a wonderful thought experiment. It shows how our perspective, our cosmic address, shapes our entire understanding of reality. We are shaped by our view of the night sky. Our ancestors were shaped by the Milky Way. A civilization in the Great Wall would be shaped by a river of galaxies. It is a beautiful reminder that there is no single privileged viewpoint in the universe, only different perspectives, each with its own truths and its own mysteries. Let us return to the force that sculpts all of this: gravity. It is the most familiar of the fundamental forces, yet it is also the most mysterious. It is by far the weakest. The electromagnetic force that holds a tiny magnet to your refrigerator is trillions of times stronger than the gravitational force between them. Yet, on the largest scales, gravity is the undisputed king. Why? Because it is always attractive, and it has infinite range. While positive and negative electrical charges cancel each other out, every particle of matter exerts a gravitational pull on every other particle. Over cosmic distances, and with immense collections of matter, this incredibly weak force adds up. It becomes the dominant force for shaping the universe. The Great Wall is the ultimate expression of gravity's patient, relentless power. It is what happens when you let the weakest force in the universe work on the largest possible canvas for the longest possible time. It is a masterpiece of accumulation. This dual nature of gravity is a wonderful metaphor. In our own lives, small, consistent, positive actions can, over time, accumulate to create profound and beautiful structures. Patience and persistence can build things that seem impossible at the outset. The Great Wall is a cosmic lesson in the power of small things adding up. The gentle pull between two atoms, multiplied by trillions and enacted over billions of years, can create a continent of stars. As you rest, let this thought comfort you. The power of gentle, persistent forces. The slow, inevitable victory of attraction and connection over the vast, empty distances. We have spoken of the Great Wall as a structure in space, but it is also a structure of time. Let us think about the different time scales at play. There is the travel time of light, hundreds of millions of years for us to see it. There is the orbital time of a star within one of its galaxies, also hundreds of millions of years. There is the time scale for two galaxies within a cluster to merge, which can take 1 billion years or more. And then there is the formation timescale of the wall itself, a process that has been ongoing for over 13 billion years. These are numbers that defy human intuition. Our lives are measured in decades, our civilizations in millennia. The very geology of our planet is measured in millions of years. The timescale of the Great Wall is a different order of reality. It operates on what is sometimes called deep time. To contemplate the wall is to contemplate the vastness of time itself. It helps to dissolve the urgency and anxiety of our own fleeting moments. Our daily worries and fears shrink to their proper proportion when viewed against the backdrop of a structure that has been calmly assembling since before our planet even existed. This is one of the great gifts of astronomy. It gives us perspective. It connects us to a story so long, so vast, that it provides a sense of peace and stability. The Great Wall was there long before us, and parts of it will be there long after we are gone. We are a brief, conscious moment allowed a glimpse of this eternal, unfolding story. Feel the deep, slow pulse of cosmic time. Let it soothe your own internal rhythm. Let it carry you into a peaceful, timeless sleep. Finally, as we prepare to drift completely into sleep, let us hold the image of the Great Wall in our minds one last time. Do not see it as a complex scientific object. Do not worry about the numbers or the theories. See it simply as a thing of beauty, a ribbon of light woven from starlight and time, stretching across the velvet blackness of space. See the soft, glowing cores of its superclusters, the delicate, intricate patterns of its filaments. See the deep, peaceful darkness of the voids that surround it. It is a piece of cosmic art, sculpted by the laws of physics. It is a silent symphony, played on instruments of gravity and light. It exists, whether we look at it or not. It is part of the fundamental reality of the universe we inhabit. And knowing it is there, this silent, majestic, impossible structure can be a source of profound comfort. It is a reminder that the universe is not a cold, random chaos, but a place of breathtaking order, structure, and emergent beauty. It is a reminder that even in the greatest of darkness, there are great walls of light. Let this image be your anchor as you let go. A silent, steady, beautiful presence in the vastness of your own inner space. A cosmic anomaly that makes the universe and our ability to wonder at it all the more precious. Breathe in its ancient light and breathe out into the peaceful, silent void of deep and restful sleep. And so, our journey to the Great Wall comes to a gentle close. We have traveled across hundreds of millions of light years and billions of years of cosmic history. We have seen how a simple, elegant idea of a smooth universe was challenged by the discovery of a structure so vast it should not exist. We learned that this wall is not a barrier, but a vibrant, luminous thread in a grand cosmic web, an architecture built by the patient hands of gravity and dark matter, from seeds planted in the first moments of time. We have floated through its bustling superclusters and rested in the profound silence of the voids that define it. The Great Wall remains a source of wonder. It is a landmark that pushed the boundaries of our knowledge, forcing us to think on a grander scale. It reminds us that the universe is always more complex, more beautiful, and more mysterious than we can imagine. It is a testament to the power of observation and the unending human quest to understand our place in the cosmos. Thank you for joining me on this peaceful voyage tonight. I hope it has brought you a sense of calm, wonder, and deep relaxation. If you enjoyed this journey, please consider liking this video and subscribing for more lectures for sleep. Your support helps create this quiet space for others. And now, I leave you with a final thought to carry into your dreams. What cosmic mystery, big or small, brings you the greatest sense of peace? Feel free to share your thoughts in the comments when you awaken. Until next time, sleep well and sweet dreams.